All right, moving on to problem number 9. We're supposed to be figuring out how many molecules are in 82 grams of propane. So we know how many grams of propane we have. We do not know how many molecules. So starting with 82 grams of propane, since we're dealing with grams, we do need to know the formula for propane. So this is an organic molecule. Remember that prop, that prefix means 3 carbons, and the ending ane means it's an alkane, so all single bonds between those carbons. So we're filling these in with hydrogens, so the formula is C3H8. All right, so now we're going to move grams to the bottom. And something we haven't encountered yet is we have not gone from grams to molecules. And you can't. You have to go to moles first, because we know how many grams are in a mole. We know how many molecules are in a mole. But we can't go just from grams to molecules without converting to moles first. So I'm going to put moles on top. And remember, 1 goes next to mole. My molar mass is going to go next to grams. So over here on the side, I'll calculate the molar mass of propane. 3 carbons, 8 hydrogens, and let's look at those masses. So carbon's mass is 12.01. Hydrogen's mass is 1.01. We can go ahead and multiply those. So we get 36.03 times 8.08, or sorry, that should be plus 8.08. And that gives us 44.11 for our molar mass. All right, now we're not done. We still have to solve for molecules. So I'm going to move moles to the bottom. I'm going to put molecules on top. And remember, I put a 1 next to mole, and next to molecules, I'm going to plug in Avogadro's number. So this is a 2-step problem. We first have to divide 82 divided by the molar mass, and then times Avogadro's number. And we get 1.12 times 10 to the 24th. Molecules. All right, moving on to problem number 10. We're trying to find the mass of 1 atom of mercury. So we know how many atoms we have. We don't know what the mass is. So starting with atom, I'm going to move atoms to the bottom. And once again, just like with molecules, you can't go straight from atoms to grams or grams to atoms. You have to go through moles first. So on the top, I'm going to put moles. How many atoms are in a mole? Avogadro's number. Now I move moles to the bottom, put grams on top. 1 goes next to mole, and here is where I'm going to put the molar mass of mercury. Looking on our periodic table, mercury's mass is 200.59. And plugging that in, we're going to type in 1 divided by 6.022 times 10 to the 23rd times 200.59. And we get 3.33 times 10 to the negative 22nd. Now, if you're paying attention to significant figures, since our original number was just 1 sig fig, we would round this to 3 times 10 to the negative 22nd grams. Okay. So moving on to our last problem. Moles of hydrogen in 79.31 grams of carbonic acid. So we know how many grams, we don't know how many moles of hydrogen. So I'm going to start with what I know, 79.31 grams. Remember, carbonic acid ends in ic, so that's carbonate. -2 charge, so you need 2 hydrogens, H2CO3. Canceling out grams, I'm going to move grams of carbonic acid to the bottom, moles of carbonic acid to the top. 1 goes next to mole, and I'm going to have to find carbonic acid's molar mass. 2 hydrogens, 1 carbon, 3 oxygens. We've used all of these already, so I'm going to go ahead and just fill in those molar masses. Hydrogen is 1.01, carbon is 12.01, and oxygen is 16. So we end up with 2.02 plus 12.01 plus 48. And I get 62.03. It's going to go right here. Now, you might be thinking that we are done with the problem. We're actually not. The problem asked us to find moles of hydrogen. We've only found moles of carbonic acid. So we got to go a little bit further with this problem. Now we're going to move moles of carbonic acid to the bottom, and we're going to put moles of hydrogen on the top. So basically what we're saying right now is how many hydrogens are in H2CO3? The answer is 2. So for every 1 mole of carbonic acid, there are 2 moles of hydrogen within that molecule. I know that can be a little confusing, but when in doubt, just bring your labels down. Remember, we're canceling units, so whatever's on top has to go on the bottom in order to cancel those out. So grams of carbonic acid cancels out, moles of carbonic acid cancels out, and you're left with moles of hydrogen. So first we're going to divide 79.31 divided by 62.03 times 2. And we get 2.557 moles of hydrogen. Now there is another option. If dimensional analysis is confusing to you, you can also use this flow chart. The only downside is when we take the test on moles, you won't be able to use this flow chart. You'll have to have it memorized. I prefer for you to use dimensional analysis, but sometimes I find that students like visuals like this. They like memorizing charts like this. So if that's you, here you go. So the way this works, if you are converting from grams to moles, you're going to be following this top arrow, which means you're going to divide by the molar mass. If you're doing the opposite, if you're going from moles to grams, you're going to multiply by the molar mass. So notice grams to moles, the molar mass is on the bottom of the dimensional analysis setup. So that just means divided by molar mass. Going from moles to grams, the molar mass is on the top, meaning you're multiplying by it. Now, whenever you're going from moles to molecules, sometimes this is also atoms. Whenever you're going from moles to particles is a better word. That's when you're going to multiply by Avogadro's number. And vice versa. If you're going from molecules back to moles, you're going to divide by Avogadro's number. And notice for that some of those last problems we did, we were going from grams all the way to molecules, or molecules all the way back to grams. So if you're going from grams to molecules, you have to follow both of these top arrows. So first you would divide by the molar mass, then you would multiply by Avogadro's number. If you're going in reverse, molecules to grams, first you have to divide by Avogadro's number and then multiply by the molar mass. And for that last problem we did together, if ever you're asked to go from molecules to atoms, they're usually asking you how many atoms of a certain element is within a molecule, like how many atoms of hydrogen are in calcium hydroxide. So the answer would be 2. So if you're going from molecules to atoms, you'd be multiplying by 2 for this example. And if you're going from atoms to molecules, you'd be dividing by 2. So whichever you prefer to use, dimensional analysis or the flow chart, either one is fine. And please let me know if you have any questions.